To continue with the previous assembly, proceed to insert a straight gear and a bevel gear from the tool library. Remember, the module between both gears must be the same. In this case, 0.5 millimeters will be used. Use the slots mechanical relation so that the gear only moves along the guide. Before proceeding to establish the mechanical relation between the two parts, define the optimal initial position of the pinion using the tangential relation so that, at the start, one tooth touches the other. Now proceed to omit the tangential relation to generate the mechanical relation. For the straight gear, simply click on an edge, and for the pinion, click on the curved surface. Define the pitch diameter, dp, as 5 millimeters, which is derived using the formula dp equals module, m, multiplied by the number of pinion teeth, z, with 0.5 as the module and 10 teeth, resulting in a 5 millimeter pitch diameter. Insert the hinges. Establish the basic relations to fix one part of the hinges. For the second part, apply the hinge mechanical relation. Limit the angles to define the range of movement. Finally, check the proper functioning of the hinges. As you can see, the faces that have been selected in the last field are inverted, so you should proceed to invert them. Great. To practice, try to do it by yourself by looking at the drawing and following these steps.